Today we're going to talk about fixing a Dataeast CPU board. This one happens to be out of, I don't know if you can read that on there or not, but it's out of a Jurassic Park. The game turns on but essentially does nothing. And this little contraption I got over here is my WPC slash Dataeast test fixture, also I guess System 11 to some degree, where I can turn this on, and I've got a power supply here providing 5.24 volts and 12 volts. So happens to be running a WPC CPU board and dot matrix driver board, but I'm not using those right now. Instead, I am running a Dataeast, you can see my little light there, a Dataeast display driver board, and obviously a dot matrix display. The other thing I'm using is this little device. I bought this on eBay. It's basically a miniature scope. It's about the size of an iPhone. It's actually probably smaller. It's really cute and inexpensive at about 50 bucks, and it even came with a probe. And I lengthened the ground strap to make it longer, but other than that, it's stock. And you can charge it just like you charge your iPhone, you know, up to a USB port. So the other thing that we're going to need is a set of schematics. This is page 1 of the CPU board schematics for a Dataeast game. It doesn't really matter the game, just as long as it's pre-White Star. And we'll talk about why this is not running and how we can try and fix it. Basically, just to give you a lay of the land, all these big 40-pin chips are PIAs, peripheral interface adapters. Peripherals are stuff like lamps and switches and coils. We also have a processor chip, a 6808 or a 6802 on this board, and then an EEPROM right here at 5C that is the actual code for Jurassic Park, and then a RAM chip. And then everything else is support chips and stuff to implement, like these are driver transistors, these are driver transistors, this is for the lamp matrix, this is for the switch matrix, so on and so forth. And of course a battery pack to keep the memory alive when the game's turned off. So basically the one thing I've noticed is when I turn this thing on and I leave it on for a minute, we're getting nothing on our dot matrix screen. I mean, absolutely nothing. But if I remove the ribbon cable, watch this. Watch the score display as I remove this. See, it allows this guy to boot. So this is a separate computer. This is the display driver. And now that it's displayed, it's display driver software, which is actually Star Wars for that one. But it's not showing us anything on this guy because this guy is fully and completely locked up. So the one thing I've noticed is that after I leave this on for a minute, the 6808 is getting warm. I mean, like I can feel it physically getting hot. If I compare it to the temperature of the other chips, they're all nice and cool, but this guy clearly is not. I mean, I can put my finger on it still. It's not that hot, but it's definitely getting warm, which leads me to believe that there is a short potentially inside this chip. But, you know, I have put in a new 6808 and it has made no difference. So I know that's not the problem. I know the EEPROM's not the problem because I tried a different EEPROM from a different game and it's got the same problem. So I know that these two chips are good. Could it be other stuff? Certainly, and that's what we're going to investigate right now. So when I initially power this on, the +5 should come on, the PIA LED should come on just for a minute and then go off, and then blanking should come on. So when I turn this on, I get +5 and PIA light on, but the blanking never comes on. Okay, and the PIA never goes off. So we know that there's a problem and it's not running. So looking at the schematic, here is the 6808 chip. And we can see that there is a reset line right here, pin 40. And this must be high in order for this processor chip to run. So when the game is turned on, a little set of transistors on the board waits for 50 milliseconds or so and then lets the reset pin go high. You also need a clock signal that's at pin 39 right here. And those two things are required to let the processor run. So with that in mind, I'm going to turn this thing on and I am going to go to our little processor chip, which is this guy right here, and you can see the little dot right there. That means that's pin 1. So pin 40 is directly across from it. First, we know we need a reset, so I'll put my little probe on pin 40, the reset line, and you can see how the display jumps up, meaning that we have a high signal. As I toggle it on and off, you can see that we have a high signal, a plus 5 volts for the reset, and that's what we want. The reset needs to be high or the processor won't start running. The next thing the processor needs is a clock signal. That's pin 39. Right next to it, I'm going to put it on that pin, and you can see here that's our clock signal. And our clock is running well. It's very systematic and even. So I think we've got a good clock signal. So we've got a good clock and we've got a good reset. Now what's left to test? Turn this off. The next thing is to look at all the address and data lines on this guy. So we've got basically 16 address lines going from A0 to A15, pin 9 to pin 25, skipping pin 21, which is ground. And then we've got 8 data lines from pin 26 to 33. It's actually in reverse. Pin 26 is data line 7. Pin 33 is data line 0. So we need to look at these and make sure that they're doing something on our little scope, and looks like that they're running a program. If any data or address line is missing or looks odd, then we know that we have some sort of problem. So as we go down all the address lines, I can just tell you from experience, and this is something that you need to see for yourself, that these waveforms just don't look quite right. Like something's going on and it's not right. Also, if I look at the data lines over here, you can see that they're really doing nothing. There should be something on the data lines. I'm just getting like a high line across. So I know that there's a problem. Something's going on and it's not looking good as I probe down the data lines. So what can we do? Let's look at the schematics. And the first thing that's coming out of the processor on the address lines are these 2 buffer chips at 6C and 6B. These 2 guys here. These are 74LS244s. They basically buffer the address lines to make them a little stronger and a little cleaner for the rest of the game. So these are these chips right here, and they do fail. These are very nicely socketed, so we can pull them out and use one of these guys, which is an eBay $20 type thing, to test them, and if they're bad you'll get that ERR thing, opposed to if you put a good one in this device it'll actually tell you 74 LS 244. So given that, I can show you a trick that sometimes works that doesn't really cost anything. Here is a new 74 LS 244, and I'm going to put it right on top of the old one. Say that these chips were soldered in the board, you couldn't pull them out, you couldn't test them. You could take a new 244, and this does not always work, but you can like bend the legs so that they ride right over top of the old legs. See, like that right there, and orient the chip correctly with the notch, pin 1 in the proper direction. And then we could try turning this on, and hole and below, look at that. It boots up. So now, if we look at our LEDs, and here I'll turn it off, we'll do it again. Watch the 2 rightmost ones, they come on, but then the right one goes off and the blanking comes on, meaning that this thing is booting. And right now it's running Jurassic Park here and Star Wars there, so don't be all freaked out by that. But you will see in a minute it's doing the dinosaur thing, and there is no firmware in here to report that on the screen, but it's checking the dinosaur right and left. But you're right there, it tells us 6 balls missing, and now we are in a track mode. Really a strange track mode because Star Wars display versus Dataeast Jurassic Park over here, so it's kind of weird. But you can see that it's running. Now watch, if I take this chip and I pull it off, watch what happens. Let me get a display up, and I just pull it off. Look, the whole thing locks up. So, indeed, it looks like one of the buffers is bad. So as a test, here is the suspect chip in our little eBay $25 chip tester. Hold the button down and it says ERR. So it does in fact look like that chip is bad, but just as a double check, we'll take our good chip and put it in there, and then hold this down. And you see it says 74244, meaning that this chip is in fact good. So not only did we verify it in the game, but we can put this guy in to the nice socket that's already there. How convenient. And power up the game, and we should be good to go, because obviously you don't want to ride them on top of each other. And you can see we're booting up with the Star Wars display and the Jurassic Park CPU, and the PIAs are doing what they should. Blanking's on, 5 volts is on, PIA is off. Now, as a comparison, let's check the display here and see how things look. And you can see that the pattern I'm at, starting at A0, pin 9, and you can see that it looks completely different on our display as I go through this. Look at that. So once you kind of get used to how these things should look, it makes the job of fixing it easier because you know what to expect. And then if we go over here to the data lines, look, the data lines are dancing too. Before, those are all flat. We got nothing out of the data lines before. Now we're getting, you know, a nice data line signal. And of course our clock, just like before, and our reset. So we used a couple tools here. We used this guy, which was nice. We used this guy, which is nice, both eBay products.